still a little bit more to do with compound inequalities. These are the special cases. These are the things that don't show up a lot, but they do show up. And because they show up, we got to make sure you know how to do it. So here's going to be our first example. Okay, this would be an and graph. So we have, we should have 14a. I don't know why that's an n. That's on me. We have 4a plus 8 is going to be greater than 11a plus 15. And we also have 13 minus 14a is going to be less than or equal to 13 minus 3a. So let's get to it. Let's solve it. So we'll start off by solving this and subtract 8 from both sides, which I'm thinking is what most of you are going to do. Again, if you don't, that's okay. So 4a is now going to be greater than 11a plus 7. Subtract 11a from both sides. So we get negative 7a is now going to be greater than 7. And then divide both sides by negative 7. Remembering to, flip your inequality. So we have a is going to be less than negative 1. All right, so now this one. We would, again, subtract 13 from both sides. So we get negative 14a. It's going to be less than or equal to negative 3a. Then we would add 3a to both sides. So now we're going to get negative 11a is going to be greater than or equal to 0. Then we would have to divide both sides by negative 11. So we're going to get a has to be greater than or equal to 0. Right? Again, make sure you're flipping the inequality when it's time. So let's take a look at the graph and see what that's going to look like. Okay, remembering this is an and graph. So we have that negative 1 over here, and we have 0. And for negative 1, we're going to have the open circle and shade it to the left, right, because all the numbers less than negative 1. And for this, we're going to have from 0, and that's a filled-in circle, and all the numbers greater there. Okay, but if you look back, you should see this is an and graph. And we get a diverging graph, not a converging graph. So the fact that it's an and statement and we get an or looking graph, that means there's no solution to this. There are no numbers that we can put in for A that are going to make both of these statements true at the same time. And again, that's the purpose of an and graph. Right? Again, there's nothing we could do that would make both of these true at the same time, so there's no solution. Let's take a look at another one of these special cases. Okay, this is an OR graph special case. Now let's see what this looks like. So again, we're going to start off solving it the way we always solve these, right? We'll subtract 18 from both sides. And again, just because you're not solving it the way that I am, doesn't mean you're solving it incorrectly. If you think back, as soon as we started doing stuff with variables on both sides, you should have realized there's 4 different things you can do to start. Doesn't matter which one you do. So that's going to be 8x and minus 14. And then we would subtract 8x from both sides. So we're going to get negative 7x greater than or equal to negative 14. We divide by negative 7. Remembering to flip our inequality. So we're going to get x is going to be less than or equal to 2. So what we know is this is an OR graph, so it's either got to be that x has got to be less than or equal to 2, or it's got to be the solution to this one. So let's do this. We'll add our 15 to both sides. So we have 15x is going to be less than or equal to 15x plus 20. And then subtract the 15x from both sides. And find out that 0 is less than or equal to 20. Well, that certainly is interesting. I hope that when you saw this right in the beginning, you had that little bell going off inside your head saying, wait a minute, there's something kind of odd about this one, right? And then when you subtracted the 15x and you saw, I have no x term left. So when you have no variable term left, what you have to do is stop being all technical and stop trying to remember what everything is. Just look at the statement. Look at this. It says that 0 is less than or equal to 20. Well, the thing that should pop into your head is, no kidding. I know 0 is less than or equal to 20. But because 0 is less than or equal to 20, what that means is this is all real numbers. There's an infinite amount of numbers. Any number will satisfy this condition. This one over here doesn't really even matter anymore. Because remember, this is or. If one or the other one is true, you're good. And in this case, any number makes the right side inequality true. Again, when is 0 less than 20? Well, 0 is always less than 20. Does it matter what x is? No, x could be anything. 0 is still going to be less than 20. So obviously, with this being all real numbers, I mean, we're not going to have to spend a lot of time on the number line. All real numbers, what does that look like on the number line? Well, the entire number line is shaded in. That's all real numbers on a number line. Okay, so these are the special cases. These are the things that happen not often, but they happen. So you need to be aware of what it is. Most important thing you can do with these inequalities is think. Think about what it means. You get to that statement. Stop trying to be technical. Just think about it for a second. Okay, what would happen in this case if this were the other way? Right, if it said 0 is greater than or equal to 20. Well, 0 is never greater than or equal to 20, so this side wouldn't matter. The other side still matters, right? Because we can never get a number that's going to make this side true, but because it's an OR graph, we would have all those values that are less than or equal to 2, would make the, because it's going to make one side of the inequality true. Okay, hopefully you picked up on this. It's a lot to take in. Watch it again if you need to. All right, thanks for watching.